Good morning. This is your stats sensei, Mr. Spensey, and we're going to do a confidence interval based on the same scenario that we've been working on originally. So originally it said a nutritionist claimed that the average loss for a new diet plan is 8 pounds. So that's our population claim with a standard deviation of 1.9. A random sample of 35 individuals from a group of 25 dieters who followed the diet plan showed an average weight loss of 8.7. So we have a sample mean of 8.7. We happen to have a sample size of 35. All right. And then we're going to calculate a 97% confidence interval for the mean weight loss. All right. Our conditions, we already did those, so we're not going to rewrite them. But basically, just as a review, random sample of 35 was given. Our sample size was 35. And 35 times 10 is 350. That's less than 2,500. So we did not violate the N is less than 10%. They did not tell us it was normal, but our sample size of 35 is greater, so it's normal by central limit theorem. The other thing we're going to need to pay attention to is our parameter, and let mu equal the true population mean weight loss after dieting. So we need our equation. Our equation for the confidence interval is X bar plus or minus Z star, standard deviation of the population divided by the square root of N. So let's go back and identify those things. Our standard deviation, we said, was 1.9. N was 35. And our X bar was 8.7. That was the sample mean. And then our confidence level, they said, hey, let's do this at 97%. All right, calculate Z star. So in this case, I'm going to have to go to a specific spot on the calculator, but here we go. This needs to be 0.97. And don't forget, Z's are always centered on 0, and we need a lower and we need an upper. And this will be a inverse norm 0.97, 0, 1, because all Z scores have a mean of 0 and a standard deviation of 1. So let's go ahead and run that. So second vars, inverse norm, 0.97, mean is 0, standard deviation of 1, and press center. And we end up getting 2.1700. So negative 2.1700 and 2.1700. We only care about the positive value. So we're going to go ahead and plug in, and we have 8.7 plus or minus 2.1700, and that's times 1.9 divided by the square root of 35. So we're going to run our interval, and it's going to be a stat test Z interval, which is number 7. 1.9 is my standard deviation. 8.7 is my sample size. 8.7 is my sample mean. N of 35 is my sample size, and we want it to be a 0.97. And we end up getting 8.00 to 9.396. So 8.0031 to 9.3969. And what we're saying is we don't know exactly where the true population mean is, but we know it's at least 8, and it could be as high as about 9.4 or 9.39. Okay, so somewhere in there is where the true population average is. Some are going to lose more than that, some are going to lose less than that, but on average, they're going to lose between 8 and 9.39, and we don't know where that average is. So next thing we need to do is write our conclusion. So we are 97% confident that the true population mean weight loss after dieting is, or excuse me, lies within the interval 8.0031 to 9.3969. So after having done this, we're not 100% confident. We're not 90% or 95. We're 90% sure that the true population mean weight loss after dieting lies within this interval. All right. Appreciate you watching and hope to see you on the next one.